Hi Year 12, here's our second lesson for the topic sequences and series. In this lesson we're going to look at arithmetic sequences. The last lesson we learned what sequences are and what series are, and we learned about sigma notation. In an arithmetic sequence, we sometimes call that an arithmetic progression, each pair of adjacent terms is separated by a common difference. Now what does that mean? What does adjacent mean? Next to. So if you take a pair of terms that are next to one another and subtract them, that difference between the two of them is going to be the same for every pair of adjacent terms. So we could say that D is equal to term 3 take away term 2, or term 2 take away term 1. Here's an example. What is the common difference of the sequence 1, 3, 5, 7? You could do 3 take away 1 or 5 take away 3, but you can see it from the sequence. It's going up by 2. So D is equal to 2. Example 1, show that the sequence 4, 5.5, 7, 8.5 is arithmetic. Now we need to show this for all the pairs of adjacent terms. So for this one, and this one, and this one. So we could write 5.5 take away 4 is 1.5. 7 take away 5.5 is also 1.5. And 8.5 take away 7 is 1.5. So because D is the same, then the sequence is arithmetic. Now you can streamline this a little bit and put it all in one if you'd like, because this is true. 8.5 take 7 is equal to 7 take 5.5 is equal to 5.5 take away 4. But make sure you give the common difference at the end. Example 2, the sequence 13 and x plus 5, 8 is arithmetic. Find the value of x. So the formal way to do this is to set up an equation. The second term take away the first term would equal the third term take away the second term, like this. Be careful of your brackets here. And we just need to solve this equation now. This becomes x take away 8 is equal to 8 take x take 5. Collect the x's together. 2x take away 8 and 8 take away 5 is 3. Take the 8 over the other side, gives us 11, divide both sides by 2. X is equal to 5.5 or 5.5. Now you can do this intuitively. This point here must be the midpoint of those two. So we could go 13 plus 8, which is 21. Divided that by 2 is 10.5. That must be equal to 10.5. So don't think that you've got to do something formally. You can solve this however you would like. Let's move on. The nth term of an arithmetic sequence can be found by letting A represent the first term and D represent the common difference. Now, here is our sequence. There's our first term. The second term would be A plus D. The third term would be A plus 2D. The fourth term would be A plus 3D. And the nth term would be A plus n minus 1d. Now just make sure that makes sense to you. I said this was the fourth term, and you can see how I've got a 3 here. This is the third term, and I've got a 2 here. So it is n minus 1. And this is our formula. It's pretty easy proof. Term n will equal A, that's the first term, plus n minus 1 times the common difference. So remember when we did this question in the last video? And we did it the old-fashioned way where we had to just figure out what the nth term was. Well, now we can use the formula. So here's our formula. We don't know what n is. We know A is equal to 1, and we know the common difference is 2. So we just substitute those two numbers in and then tidy it up. And voila, look, we get the same thing. Here's another really common example. Find the 20th term of the sequence 5, 8, 11, 14. So we start again with our formula. We know that A is equal to 5, N is going to be 20, and D, a common difference, is 3. And we just substitute it in. Now, quick tip. I tend to always skip this step, and I'll just do that part in my head and go 20 take away 1 is 19. So I'll actually start here. T20 is equal to 5 plus 19 times 3. It just saves a little bit of working out. Into the calculator, the 20th term is 62. Example 3. Is 14 a term in the sequence 88, 83, 78? So again, we're going to use our formula, but this time we're going to solve for n. And we want n to be a whole number because n is the position in the pattern. So this is the first position, second position, third position. We can't have n having a decimal part. So A is 88, D is -5. So 14 is equal to 88 plus n minus 1 multiplied by -5. Expand these brackets. And collecting like terms, we've got 14 is equal to 93, take away 5n. And so 5n is equal to 79. Divide through by 5, n is equal to 15.8. So no, 14 is not a term of the sequence. Example 4. What is the first negative term in the sequence 200, 194, 188? Again with our formula, but this time we're going to use an inequality. We want to know when this first drops below 0. Now A is 200 and D is -6. So 200 plus n minus 1 times -6 less than 0 is what we want to solve. Expand the brackets and collect these terms together. I've also taken this -6n across the other side. You can leave it on this side and then multiply by negative and flip the sign, that's fine. I'm going to turn this around and the sign will turn with it. I'm also going to divide by 6 at the same time. Hopefully this is not too quick for you. So n will be greater than, if I'm reading this way, 206 divided by 6, which is 34.3. So the first negative term is going to be the one that is greater than 34.3. So the first negative term is the 35th term. You can also check your answer if you want to. Here's a past HSC question. J is making a pattern using triangular tiles. The pattern has 3 tiles in the first row, 5 tiles in the second row, and each successive row has 2 more tiles than the previous row. How many tiles would J use in row 20? We want the 20th term in this sequence. So Tn is equal to A plus n minus 1d. N is 20, A is 3, and D is 2. Substitute, and you can see how I've done that shortcut there. 20 take away 1 is 19. And into the calculator we get 41. All right, last bit for this video. Very often they ask questions that will involve simultaneous equations. Here's an example. Find the first term and the common difference of an arithmetic sequence whose 5th term is 31 and whose 12th term is 73. What we're going to do is use our formula to set up 2 equations. So here's the first one. The 5th term, and that's going to be A plus 4D, because this is n minus 1, is equal to 31. Here's the second equation. The 12th term, which is A plus 11D, is equal to 73. All right, there's our simultaneous equations. Now, quick trick. What we're going to do is do this one, take away this one. So I'm kind of going to subtract up, if that makes any sense. I'll show you what I mean. A take away A is 0. 11D take away 4D is 7D. And 73 take away 31 is 42. Divide both sides by 7, we get 6. So the common difference is 6. Now substitute back into either one of these equations, but let's pick the first one. A plus 4 times 6 is equal to 31. A is equal to 31, take away 24, which is 7. And so the first term is 7, and the common difference is 6. Okay, that's it for this lesson. In our next lesson, we're going to look at arithmetic series.